but we can, I guess, figure out what we're doing. I'm still working on the replaceable capability contract in the background here. Maybe I'll show it to you in a minute or so when it runs.
Oh, cool. Do you want to say a word or two about what you mean by replaceable capability contract? Because I don't really know what that means.
Oh, well, we were talking about evolutionary programming, how our behavior could evolve.
Okay.
And we were talking
and
about
how replaceable capability is more general than
Right.
revocable capability.
Okay.
Okay, we did a revocable capability example, and I was doing a replaceable capability.
Okay.
And basically, I was just doing the raw stuff. I mean, I haven't done the join of consent to replace the contract yet. Part of it yet. I'm just doing the raw part, but.
So that's sort of a multi-sig of capabilities is what you're working on next, right? Am I misunderstanding that?
Yeah, it's right, sort of a multi-sig. And I don't know. I mean, there's a lot of unknowns now. I mean, with the robot stuff I've done, people have mailboxes, so I can send capabilities to their mailboxes. But I'm not sure how I translate that now. I guess we can have public keys that I guess I need signed messages or something, right?
Can you use unforgeable names?
Yeah, I was going to say unforgeable names are like capabilities and
right, but there's no way I can send those to somebody, right?
You can't send an unforgeable name to somebody?
Well, I mean, how do I mean, if we have a mailbox, yes, I can. But,
yeah.
So that's and that's really the right way to do it. A way that it'll work now without mailboxes is if I can verify that. If I can take a list of public keys, and I can I can verify and have them send a signed message. That's all I'm thinking.
But you have deploy that is signed, right? So you can check if someone can do something with some deploy.
Oh, that's true. So so what can they pay? How do I? How can they pass? How can I find out who deployed it without giving me permissions? In other words, if they send me the deploy ID, I can get the auth key, and I can spend their wallet.
Can we use the similar logic that we have in multisig? Because in multisig, multisig accepts a list of public keys, right, and unforgeable names.
Yeah.
And multisig can confirm that some public key approved transaction or some unforgeable name approved transaction. So maybe you can use the same logic, right?
Absolutely,
you can,
yeah. That's what we were thinking. I don't know why I'm not.
And I'm thinking of what Mike said about sealer, unsealer. Is this the thing that is doing this, or I'm not sure. And I'm still not completely sure about how to use authentication key in Roland, because last time I was arguing with Jim, and I was saying that deploy ID is whoever executes, and this is totally wrong. So it's really not. So The deployer ID is who really deploy it, and not the who execute the code. So and the authentication key is the same. And I was just thinking, you know, oh, how can I create a contract and, you know, and ask someone to pay some reps to me? How to do it? And I really don't know.
Yeah, that for me that was always really confusing, the connection between, like, you know, okay, great, like I have access to this deployer ID thing in the POS contract, but like where does that come from, and how do I like know like where does it come from? I mean, that was always my question, kind of.
It is a public key, but
Yeah.
like encoded public key in the rolling, which is directly related to the public key of deployer who created this code.
Yeah, I'm looking at it.
I'm not completely sure how to use it, you know, in combination with authentication key. How to, if you give authentication key to someone else, you know.
Oh yeah. I think you're effed.
Well,
I mean, you can give authentication key. But,
like, yeah. Okay. So like when you actually deploy your Rolang code, you know, you want a bond or whatever. I mean, that deployer ID is what, like public key or something that you're supplying to that bond method. And so that's how they identify that, like, you're the one that deployed this particular bond, right? So like clearly that guy wants.
Can you share the screen?
Yeah. Unfortunately, I'm looking at it on GitHub, so it looks terrible, but I'll share it. Right. So I'm looking at this method right here, and so basically we're saying.
No. This deployer ID is not what we are talking about. This deployer ID is really. I think this is really the public key, but as
this is the public key. Okay, that makes sense.
I think it is.
Yeah.
But the public key in the as a bytes.
Public key as a byte. Yeah.
I think.
Yeah, that makes sense.
okay, so the row our change deployer ID or whatever that we bind to is a completely different thing. It's an ID for the deploy.
Yeah.
I
mean, it is public key, you know, inside, but it's not available as a public key. It's like more like a unique identity.
Yeah, the deployer ID for every deploy is unique.
But this is deployer, not deploy, right?
Do you guys have an example of the use of this contract? Because, like, you know, the logic of the contract makes sense, but only modulo like what these things are and how I would actually use them in practice. And like, okay, amount is like totally clear. It has to be like, you know, whatever, int, the float, like whatever you want to say. It's probably just an int because I think that's all you got in Rolang. And you know, that's a static string, so you know, not there. But like this deployer ID, like I would love to see how you so you have to generate, I mean, like a public key and private key pair, right? To even be a user of the network. So you already have this ID, right?
Yeah. Maybe I'm not saying correctly. Can you go to the get user?
Get user.
Because this deployer ID is supplied to this.
Go to the right. Oh, right. Deployer ID, yes, is supplied to this. And get user is
So
here again, but where is it defined? Here it is.
yeah.
Okay.
So
And
now,
we
yeah.
say-
So sorry. This is deployer ID that we were talking about.
Okay.
This is the thing.
This
But-
is the right one. Yeah.
But this will be created when you are deploying your bonding contract. So this will be your deploy ID of you who are deploying.
Okay.
And because in deployer ID is really public key encoded, with deployer ID ops, you can extract a public key from bytes of public key from this deployer ID.
Okay. And like, you know, this is public, right? So anybody can do this get user, right? I mean, it doesn't have like an authentication token that you have to supply. So this method is public, right? So any user can, you know, take some deployer ID that they saw and extract the public key from it, right?
But this is not really extract. This is just conversion from
Yeah.
from this to bytes.
Yeah. Okay. Right. But there's I mean, there's a correspondence, right? Yeah. I mean, like, okay, this is just like another way of encoding this public key.
Yeah. I'm not sure why we have, you know, we are exposing deployer ID as this special, this like special unforgeable name, right?
Yeah.
But it's not just bytes. It's like special name that, you know, you cannot create yourself somehow. You can only create it. This can be only created when you as a deployer, say, you know, call row deployer ID. You know.
Okay.
So there is no other way to create it.
And so then, like this public key and this deployer ID, there's some sort of, you know, map or like pair, some, you know, in this like row archain deployer ID ops or something, and that's why I can go and say like, hey, deployer ID ops channel, like give me the public key that's associated with this particular deployer ID, right?
So it's not like that. Okay. So you can imagine that for this unforgeable name, this is like a one data type in Scala. And this data type is holding public key. Really, it has argument public key bytes. So when you request public key bytes, you really just extracting, destructuring whatever is inside. You don't need to keep like separate list, or, you know, this is really unforgeable name.
Okay. Yeah, that makes sense. So this guy is almost like, in some sense, kind of like a wrapper with a public key in it, and then this is the way to like extract the public key from the router. I mean, extract is probably the wrong word, but just like give me that public key back from the
from this strange object that I cannot access. Give me public key from inside.
Okay.
And Jim, this is why I was talking about deployer ID as a public key, because it's a wrapper around public key bytes.
Yeah. So what's the point of doing the wrapper instead of just like using the public key directly instead of this deployer ID? I mean, I'm assuming this somehow takes into account like some kind of information about the state at the time of deploy or something like that. I mean, I really have no idea. That it's just guessing.
Yeah, I'm not sure why we need a wrapper. Maybe, I mean, if you have a wrapper and you cannot create it yourself, then you have some kind of way of, you know, some kind of authentication, right?
I see.
Only you can create it, and
okay.
But I'm not sure if we are using this in this way or this is just some kind of coincidence.
Yeah. Okay. So one thing when I was looking much closer at the code base, one thing for me that was always difficult to figure out is like, okay, I want to know more about this thing. Like, where do I look? Like, how do I figure out like what I should be thinking about when I see some like deployer ID, which is some argument to this I don't know, function, for lack of better words, right? I mean, it's just a channel, right? But like,
Yeah.
what is this channel doing? Like, how can I get information about that? That was something that I always kind of struggled with when I was working with the code base.
So we don't have only one way of defining these special names.
Yeah.
So this is like a special name that it has something attached. So it's not just a forgeable name. It is doing something else, right? Like standard
Yeah.
output. It's like
Yeah.
normal name, but it's doing something else. So
Can you show me in the code base like where that is?
yeah.
Cool.
Yeah, I can show
I'll
you.
stop sharing.
So one thing that we have is system processes.
Yeah. Right.
Is that from the insert signed or wait? Oh, I'm confusing.
So insert signed. I'm not sure if it is here or in some other place. Maybe in some other place.
You guys now have a better way of like generating key pairs and stuff, right?
I'm not sure.
Or just signing, not signing. What do I need? I need so for insert signed. What do you need? Because you needed to do what, like serialize the data that you wanted to put in there and then somehow sign it. So yeah, signing.
Yes.
Yeah. Is there an easier way to sign now? That was something that was always like giving me a hard time.
No. Yeah, you need to construct protobuf data structure that you want to store, and then you need to sign it off chain, and you need to serialize this off chain. Sign it, put in the deploy, and then you can put this in the registry. You can say,
Okay. And
so
am I mistaken? I thought you had a JavaScript like program. That
but I didn't do the whole process. So
okay.
Yeah, I don't have any examples. This is what I want to say.
Okay.
Yeah. I wanted to do this, but I didn't have time to.
Yeah.
But yeah, it's difficult to do if you don't use Scala. It's difficult, and then even in Scala, it's not easy. You don't have like a nice way to do it.
Yeah.
There is no some kind of API that you can call on Node and do all of these things, and so it would be nice to have like in evaluator. Why not have special name to do all of these things?
Yeah,
I mean,
that would be great.
Rolling, and you can just supply whatever to Rolling. He will give you result back, and you can do whatever you want. So. So one way of defining these special names is as a system process.
Okay.
So you can say this name. It is encoded with this like tokens or tags. So this is the name. This is like encoding for standard output. It has only one parameter. And like reference is also this, And then when you have this context, you can call this standard out. Standard out. There is the. So here is the definition. but somewhere is the function that is called. Let me see. I always searching for function when so.
Oh, here it is. 113, right?
But where is called?
Oh.
Standard. Oh, here is the defined as a contract standard out. So when you call, when you send on standard output channel, this function will be called, and you will have your argument here.
Yeah.
As a part. And so this will be called when you call standard output. Printing on the argument on the part.
Yeah.
So this is one way defining as a system process. Another way is with normalizer. Normalizer env. So this is how with this normalizer. So normalizer is like context for execution. So it's very similar to system processes, and maybe we can unify this in one way. On one PR team, and I'm not sure who else. They were discussing this. You know, how can we combine this?
Oh yeah.
It's not. The problem is that some rolling you are executing in the interpreter or evaluator, so you don't have all the blockchain stuff. So it doesn't make sense to have a deploy ID when you are in evaluator. There is no meaning of deploy ID.
Oh yeah. Okay. Sure.
So
right.
this is how this is injected in execution of in deploy code. So in addition to system processes, you have deploy ID, for example. You know, and this is also like another forgeable name. Like this unforgeable name is G deployer ID. This is like, and this is exactly what we were discussing, right? What is inside? So what you are asking, right? This is exactly what it is. You know, it's just another data type that accepts by string. You know, it has this public key inside.
Yeah, yeah.
So and now when you want to extract this public key, I think this is system processes. I think I saw it here. Yeah. So you see here that the first argument must be string, because this will be matched. And the second argument is the deploy ID, data type, and it holds public key. So it will just produce whatever it's holding inside this public key.
Yeah, that makes sense. Oh yeah, sure. So it gives you back that public key as a byte array.
As a byte array, as one argument and acknowledgement channel.
As a byte array in Rolang, that is the part of only one term, which is itself. Yeah. So
this is like just like naming of special functions that will be executed. This is not ordinary forgeable name. It's doing something else.
Yeah, right. It's this special unforgeable name. So what type do the unforgeable names have? Are they I totally forget.
So what is deployer ID?
Yeah.
Deployer ID is deconstructed here.
Oh yeah, there it is. G unforgeable, right? That's the data type that tells me I'm dealing with
Yeah. So this is constructor. So when you supply bytes, you get G deployer ID, and G deployer ID is really a protobuf type, which is part of unforgeable name, but where can I see this?
Okay, well, that answers one question about why I was so confused about this, because I didn't realize that we were talking about these protobuf types. Yeah, that.
Yeah, they're defining. They have some hierarchy, right? So this should be unforgeable name. Let me think where it is. It must be in protobuf file. Yes. So G unforgeable is can be one of these instances. Can be G private, G deploy ID, G deploy ID in each authentication.
Oh yeah, okay.
So G private is most of the unforgeable names are G private.
Okay. This is like when you do like new some name, like that's a
Yeah.
G private.
Yeah, and inside the G private you will have a random generated hash.
Yeah.
Our random, like predictable random.
Yeah. Right. Pseudo random.
Yeah.
Deterministically random.
Deterministically random.
Yeah. Okay. And then deploy ID is another one, and deployer ID is another one, and then the authentication token is another one. Okay, cool. Yeah, and so these G unforgeable things are like there's no rolling constructor for G unforgeables.
Yeah. I mean, there is not, but if you say sorry, I want to go back to normalizer. When you ask for deployer ID, you are really creating deployer ID inside the role. I mean, you know, with the new something, you are creating a forgeable name. But I think what you are saying is you cannot create any unforgeable name. There are specific rules. Right?
Oh yeah. Okay. Right.
You must use new, or you must use the special names, special strings or constructions.
Yes.
This is why
you don't have a choice of that random number that gets fed into into the system.
Yes, or this deployer ID. Whoever is deployer for this deploy, you will get the same thing. So
yeah, cool.
So from that perspective, we can have we can maybe create more like easier way to manage all of these names or create new ones, or because in evaluator it would be nice that we have lots of different names like that, right? For HTTP, for signing, for creating this signed registry entries, or and this stuff on blockchain doesn't make any sense, but in the evaluator it will be nice to have.
Yeah, right. But Roling's not just a smart contract language, or at least that's not the point. You want it to be general purpose. So you want those features.
Yeah, I was thinking that.
Oh yeah, I was just gonna say, like in that sense, it kind of is reasonable to have the two separate things, and by things I mean like the system processes, and those are like the guys you have access to if you're just like in eval mode or whatever, and then you have like the normalizer environment, and those are the guys that you have access to if you're like on the blockchain or whatever. I'm not really 100% sure how you distinguish that, but
and I would like to have this as a like normal list, and you can say when you're creating a blockchain rolling, you just take the filtered list, or
okay.
So you don't need to manage two different notions in your code, right? You just say I have all of these things, and I will supply to this part of this list.
Yeah,
Because
yeah.
now you need to think, oh, is this a normalizer or is system process or is I think it's one another way to create, but I'm not completely sure. Yeah, I mean, it would be nice if we can reduce the core part of Arnold. So, for example, if in evaluator you want to have like some crazy unforgeable names that are doing I don't know what, why not create this as a plugin, right? So you can have like a core Arnold, and then you load you know plugin for HTTP for you know different stuff for your role.
Yeah, yeah.
Or maybe like special names inside the blockchain, right? So why not? So if I find out for some unforgeable name on the blockchain, why I cannot put additional stuff on that channel on my node, just on my node, so I can you know say you know this forgeable name will be my standard output on my node. So you know whatever is happening on blockchain on this channel, I will see this in my standard output.
Yeah.
Or you know you are creating HTTP request to something and you know you immediately have reporting. You know.
Yeah, that's an interesting idea. I mean, how would like that work? I don't see how that would work currently.
Oh, in the same way. So here is the special string, right? But in the same way, you can say I will detect G private, and whatever you are sending on this G private, in the same way you can see this as a system process standard output. So you will have this kind of argument. This argument will be par. Right?
Oh yeah.
So instead of calling this special name, you can say, oh, but I know the hash of this, right? Because you know I'm looking in the internals of Rolex. Because I was thinking that we are assigning special where it is special. I think it's maybe in runtime. The special special names or G private unforgeable is a hash of bytes, and this is like special hashes, right?
Okay.
So this is unforgeable name with this hash in a sense.
Yeah.
So I was thinking why we need these special names, why we don't do, why we are not using the same unforgeable names and just say, oh, but standard output is this hash. Why assign like special byte in the code? Why not just say, oh, this is standard output, and when I first run my node, I will say this hash of unforgeable name, this is my standard output. I mean, all names are the same, so.
Yeah. Well, when was this code written?
Yeah.
No, seriously. Like, what's the annotation say?
2018.
Oh yeah. Yeah, August 2018 is pretty old.
Yeah, and we see how new names are added.
Oh yeah, right.
Sometimes. But yeah, what I want to say is that they are just another way of uniquely define a channel name. It is it's encoded in this way. This is like an enumeration. You say, oh, this standard output is this code, and then I will reference this. For me, maybe it would be easier to put all of this information in one place, and so you can say, yo, I'm defining new special channel. This is the name, this is everything, and then.
Yeah.
But I was using this to track merging conflicts.
Yeah.
Because in the changes, you see this name. So you see 0 as a name. So I know that when I see this, oh, this is standard output.
Yeah. One question that I have about size of cold storage is, do we know the size of the current mainnet? Like how much data to download, the cold storage associated with, like the current mainnet state? How large of a file is that?
I didn't inspect mainnet files, but cold storage should be bigger than the history try. Although the file that I have for testnet is bigger for history than for cold store. So for cold store is well. First of all, for LNDB, file size is not really the file size, because LNDB can reserve part of the file just for to be empty, and it will never shrink. So if LNDB in one moment concludes, oh, I will take I don't know how many megabytes, the file will be bigger but probably empty. So I noticed this when I was copying the whole history in different chunks. I noticed that if I'm using like very big chunk, I get smaller file. But I'm copying the same data. But when I'm using smaller chunks, I'm getting the bigger file. But the file is probably not full. It's just reserved. So in one case I can have maybe 400 megabytes, and in another case 500 megabytes. But I'm copying the same data, so it should be like completely the same. So now, file that I have from testnet is for history 14 gigabytes, which is huge.
Yeah.
And the cold store is 1 gigabyte.
The history is 14 gigs, and the cold store itself is 1.
Yeah, I think
that's so strange if you're just like looking at hashes in the history.
Yeah. Uh, 10 gigabytes. Sorry, 10 gigabytes, and the cold store is 1.5, 1.2.
Weird.
And when I copy this, you can see here different sizes of chunks that I've tried to copy. So with 500,000 in one chunk, I get even smaller than for 100 megabytes. And for chunks of 50,000, I get 500 megabytes. It's not always the same, right? So for 35,000, it's 400. Yeah.
Yeah.
I'm not sure how LNDB reserve part of the file. Maybe it's doing some dynamic check or something.
Yeah, because it seems weird. You're taking 10 times any files and getting like something 2/3 the size.
Yeah. I mean, this is I'm copying only one root.
Okay.
So this is important. Yeah.
Oh, okay.
So this 10 10 gigs that I'm copying, I'm not copying everything. I'm just copying the last state, the latest root. And this is like, for me, that was important information because so this, the one state, like the state of the whole network is really less than 400 megabytes. Right? All the other stuff is just all the previous state, and you know. So now I want to copy the cold store to see, you know, of this 1.2 gigs, what is the only part of the last state.
So what goes into the cold storage? Is it only last finalized blocks, or is it every block that's created?
Cold store is just data referenced from the history. And data, I mean raw data, integers, arrays, maps, just data. Right? Okay. Whatever you send on the channel, it will end up in the cold store, and hash will be referenced in the history. Okay. So it doesn't contain any you know, relationship between anything. It's just the raw data. You know, okay, right.
There's no structure to it really. It's just there's no blocks, obviously.
It's just the hash. The hash of the data is the key. The serialized data the hash is the key, and the data is the value, and that's it.
Okay. Yeah, cool. I would like to know how big the mainnet cold store is, but maybe cold store is not like even the right thing to ask about. Maybe it's more of like block store or something. I'm not really sure. Like,
so but for block store you're not too much interested, because if you think about the last finalized state, then you can abandon all of the previous blocks.
Oh yeah.
You don't care, right? Because you will never go back. So when node starts from this last finalized state, it cannot go back. So this is also what we need to implement, so that we can communicate to user, you know. I'm the node and I have all information from this block. All the previous stuff I don't have. So you know, there is no point to ask me, you know, for anything. But this must be clear, because there, if node just say, oh, I don't know for this information, you know, what does it mean? Is it faulty, or, you know, so we need to implement some kind of way of, you know, responding to users and say, you know, I don't have this information.
Cool. Hey man, it was good to talk about all this stuff and think about all of these Archain related things again. I should probably go in here, and it's always good to see you guys. So I was thinking, hopefully next weekend I'll probably have some time, if you guys want to meet to like specifically talk about category theory. I would be super interested in doing that. And yeah, like I said in the message, like I've you know, so well, first of all, I got through all of those the Bartosz lectures. They're
both levels.
All three,
all
man.
Three. Okay. Well, I'm well into 2 now, but I realize I haven't done enough homework. You know, I've done the first series too fast to really internalize it. But could you, I wouldn't mind spending some time preparing for next week if you could suggest an area of review or something that you would want to cover, and then I'll dig into it at my level.
Oh yeah, sure. Yeah, and I mean, if you want to, you know, have like, if it will help you if you want some accountability and say like, hey, you'll present some particular thing for like, you know, some portion of the meeting or something like, you know, if you want to commit to that or something, I would be fine with that.
Yeah, that's a good idea. Okay.
Okay.
That will keep me busy then, and
Yeah.
let me give me a project to work on.
Yeah, cool. Okay. Yeah, and I mean, if you want to, you know, make a suggestion as to something you thought you understood, and then as you're going through this second series, you're like, oh wait, maybe I don't understand that as much as I thought. Just like, you know, drop a message in there and say like, hey, you know, like I'll look into this particular thing. Cause pretty much anything you want to talk about, I'm gonna be interested in hearing it again.
Okay.
Because I mean, I have this perpetual issue of like, okay, stuff makes sense when I'm listening to somebody talk about it and when I'm reading about it, and then, you know, 2 weeks goes by and then I'm like, do I know that? I don't remember, you know. So for me,
I remember parts and pieces of the things that I have understood at one time.
Yeah.
But, you never know. It's hard to know which part's going to stick with you, and if you're lucky, the right part sticks.
Yeah.
Do we take a half a minute and look at the replaceable capability? Just want to get feedback on how it's going to be updated. And
I got to get going, but I mean, you know, obviously, if these guys want to take a look at that, that's, you know, up to them.
Yeah, sure.
Yeah, I could stay.
yeah, and so Monday morning before the
Monday at 9, I think is what we said, right? And we're talking about the makement stuff.
right makement mostly. We might want to do a little bit on the multisig anyway. Or also we might want to look at some of that.
Yeah, I'm definitely less familiar with the multisig stuff, but like I'll always try to understand it more. If that's
well, if we can get through the makement, that'll be plenty.
Yeah. Okay. Cool. I think I can help out with the makement because I was definitely digging into that pretty deeply at one point in time. So yeah, I'll take a look at it before Monday morning, and then hopefully I'll have something, you know, relatively coherent to say about it.
Hopefully I'll get a chance to look at it and see what my questions are. Not what I meant. Okay.
Yeah. Cool. All right. Good to see you guys.
Thank you so much. Bye-bye.
See you later.
So Thomas, we have it's very simple replaceable capability. Contract, it returns current, which is a contract that reads from the capacity, you know, it stores the capability in the capability channel. And really, we would need a replaceable capability with 1 argument, 2 arguments, 3 arguments, 4 arguments. This is just the one with 1 argument.
Okay.
So
multiple arguments, you mean multiple capabilities or?
Multiple arguments to the capability.
To have multiple capabilities. This is why you want to have multiple arguments, right?
Well, it's because, you know, capability might be to transfer funds or something. It might take 3 arguments from to amount.
Oh, I see. Okay.
In other words, when
I see.
In other words, when you call this capability, you may send it some number of arguments.
Yeah, I see.
I'm assuming it's. I'm just implementing 1 here.
Okay.
So that so that when you call it, this is the current is the replaceable capability. When we call current, it just reads the current capability and it executes it with 1 argument.
Okay.
Oh.
Yeah. Okay.
Contract, yeah, current with an argument, right? Okay, and then we have replace, which this is doing a peak.
Yeah.
At the capacity channel. This is reading the capacity channel to replacing it with a new capability. Okay, and what our intention is to make this replace like a multisig, so that we have to get more than one signature, basically. I mean, one way to do it is that when we return the replace capability here, instead of replace, we send a set of unforgeable names, A, B, C. We give, and then we do a join of receiving on A, B, and C to do the replace.
Yeah, yeah. Is this sealer and unsealer is doing?
Is that what we're doing?
I think this is very, very similar.
Okay. Very good. That's all. Yeah.
Multisig.
So it's a solved problem, basically. I just have to copy.
Yes, sealer.
So if you put 3 seals on it.
So sealer, unsealer is just, it's very similar what you did. Yeah. It's almost the same.
Well, I didn't seal it here, really. I just gave one.
So your current is the sealer and your replace is unsealer.
Really?
Can you share your screen, Tomislav?
Yes, yes. So here a sealer and unsealer are returned. And sealer will put will relate something to the box. And box is inside reference, right? But here we are using also the map of the whole store. But unsealer is this box is like a capability, right? And it can find a reference in the map for this box, and it can get the value. Does this make sense? So this box is not directly used to send anything. It's just used for reference for this map as a key, right? So you supply box to someone, and you say, you know, only I can interpret this box, because this box is key in my map, like in my internal state. This is your internal state of your contract. So that so now I'm thinking that you can have another unforgeable name that you are giving to someone to replace capability, right? You can send unforgeable name, and whoever gives you this unforgeable name, like this in here in unsealer, you can check, is this something that you recognize?
I don't really get what you would put in a box. I mean, I'm missing something basic.
So box is your capability, right? Maybe the box is not really the right name.
It's not what I did. This box is a map. Okay.
No. Box is not the map. Box is an unforgeable name created here.
Right.
Box is a key, one key in this map. Map is a private, right? And the box is a key. So only if you have the right key, you can extract the value from this map.
Right.
So this channel box is used as a reference, not to send anything or receive. The sending and receiving on this channel doesn't do anything. It is not used here. So when someone wants to unseal or to get the value related to this unforgeable name box, this code will first try to find out, oh, do I recognize this key? And if I do, I can extract the value. This is very similar how you can in object-oriented language, how can you protect something that is private, right? You create some kind of reference, and reference is like a memory location, so that no one else can forge this kind of reference. I mean, you know, you cannot create the same reference as some other object. This is not available to you in the object level.
Yeah, I guess I have to read some of the background stuff. I mean, this seems to be a value store.
Yeah.
Where
yes.
You have to have a key to get a value out.
Yeah, you supply the value, and you will receive the key. And only with this key you can get the value back.
How does that work?
How does that work? Didn't hear you.
I mean, how does that relate to multisig? The multisig vault, supposedly, and you can seal and unseal. I see. So each signature seals something, I guess.
So when you create, so I'm not sure where the make sealer unsealer is called.
So I guess if you do a join of all the seals,
so this is how you create. When you call make sealer unsealer, so whatever you put here, Carol unsealer. So we need to see how create. Okay. So to create multisig, you need to supply unsealers. And unsealers, so this is creating sealer unsealer is like authentication token, or and this is a map. And this is a map, and unsealer needs this. Who are using sealer? It's not used here.
The sealer sets a value.
Yeah, and what is the value? What the value is? So you don't want to give sealer. Sealers is your sealer is sealer is like a setter, and this unsealer is a getter. So you don't want to give sealer to someone else, right? Because this is what you are writing.
Right.
And who can get the value? Whoever has a reference to the box. So here is the reference to the box. Yeah. This is the only way to get to the box. So when you put something in the sealer, you can then call transfer with the reference to the box. And then transfer can extract data from the inside. Where is this? Okay, it can verify, and then
Sealer unsealer pairs are similar in concept to public-private key pairs. The sealer is like an encryption key, and the unsealer like a decryption key.
Where are you reading that?
The provided primitive make brand pair makes and returns a pair. When a sealer...
Do you want to share?
Is that a wiki article?
This is the capability, ODE capability from eWrites.org. This is the link that
Mike Stay?
no, Dan, one of the links that Dan shared. From objects to capabilities.
Mm-hmm.
So this concept is, well, certainly central to e-rights.
Yeah, so Mark Miller was saying in one of the videos, you know, you don't want to do encrypt using encryption always, right? You want to do this, you know, when you entering on some safe place, and after that you can use internals of your language to do this. So from that perspective, it totally makes sense to say, you know, this is like encryption, because you do encryption on the boundary of your like execution environment, right? So when you inside, then you can use construct in the language to do the same thing, right? You don't need to encrypt, decrypt, right? Because you're protected, you're in a safe environment. You know, there's very strict rules what can you do and not. So when you create this sealer and sealer, this can be like encryption. Because there is no way that you can, you know, somehow say to Roland, you know, I know this box, you know, you cannot fool validator to say, oh, you know, I can extract this value. You cannot. So.
Okay,
so they must be using some kind of reference for this box. Make brand pair. So yeah, this is like internal to this make brand pair. Silver and silver.
So I'm not sure. This is classic example is the can and the can opener. Only by bringing the two together can we obtain the food in the can. Of course, this example here gets tuna. I thought that was the can.
What is the can? The can and can opener.
So we're going to seal the tuna. And the sealer's going to seal it, and then it sends the sealer to the tuna, and then.
Oh, so envelope is opener and unsealer is no. Because envelope is like a key, right? When you seal the tuna, you will have envelope, and you need to have unsealer and envelope to get back the tuna. What does it say? Oh, if the envelope is the can and the unsealer is the can opener. Okay, like reverse. Yeah. If the envelope is the can and the unsealer is the can opener, specific to this brand of cans, then tuna is the food. Okay.
Well, tuna, huh? Oh well. But we're going to go over this Monday, so I guess we'll go over that. We're going to get an unseal. We're going to do a make brain. We're going to get a sealer and an unsealer. We get that in our make bit.
So we want to adopt this language.
Yeah, we're going to have to learn that language. So.
the sealer and sealer is in multisig. I'm not sure if it is in make mint.
It's not there.
In the multisig.
Yeah, I know it's in multisig.
I'm not
I
sure
thought-
that mint make mint is written in this way, because Mike was saying that now we are using this authentication token, so
The what?
and we are not using sealer and sealer. It is in multisig, but it's not in.
So we don't need it? Where am I? Okay, so we make the purse. And then the purse uses the sealer unsealer.
It uses only unseal to
Only
get
unseal.
source get decr. This is like decrement or.
We do it.
So this get decrement is creating a sealer or this end, right? But why this decrement is not protected in some way?
Well, maybe you can try to, I don't know, but probably be lazy. But,
Oh, so here this get decrement really means, so this decker function, this private function, decker, which reduces your balance. This function, it is immediately after make purse, right? Yeah.
Decker.
Yeah, I think now you are on more on top.
Well,
Yeah, here exactly. What is now selected in the orange.
So you get the Decker from zero to balance.
But yeah. But it is important that we are sealing this function, right? So we are protecting this function with a sealer. So if you want to get access to the decrement function, you need this envelope, which is created with the seal.
The unsealer.
So that you can call unseal with this envelope and supply amount, because with unseal you will get a decker function.
We're doing the seal here, right?
Yeah, but we are storing the value that we are storing is this private function to decrease the value. This is what we are holding, right? We are protecting decrement function, and with unseal we can get back this decker function, and we can supply amount to this function. Yeah, because this amount will be directly supplied to decker amount argument.
Right.
And then we increase balance. So this deposit
What is
deposit in the purse.
What does two mean here? Is that a definition? Everything is two.
So I'm reading this as a member function. It's probably something like that.
So you can deposit.
Like in the purse, you have this.
But deposit, you're adding the amount. And why is decrement?
But this source is not the same purse, right? This source must be the source, another purse from where you transferring.
Ah, yes.
So
In our make mint, I think we are using authentication key for this purpose instead of sealer and sealer.
you know, we're using a decker here, right?
Yeah.
There must be some relationship between the decker there and the decker here.
It is, but maybe it's not completely the same because we don't have.
We don't have sealer unsealer.
Yeah.
And I guess if we were to make a sealer, unsealer.
Yeah, get balance, split. Deposit. So in deposit, we can see how to check balance of this person.
As of this decker channel.
Can you go a little down?
So it's actually doing a
Oh,
transfer.
it's here.
It's doing a transfer from this source, right?
Yeah.
To this purse.
And how this source is? Oh, this decker equal to source decker. Okay, so this decker channel, source decker channel. Oh, so we are calling source decker which is equal to this decker. Okay, here we are calling
This looks like
on the
it's
source.
this looks like it's
Yeah.
doing like an unpack or something. The way that cover. Well, we're just getting success or failure. Huh?
But I'm not sure how this is authenticated on the source. Yeah.
Well, the only thing it does in terms of the,
This bundle is like so no one can get to the decker. How? So from that perspective, so I was thinking that if you want to somehow transfer rep to someone else, right? You want to create this decker function with specific amount and say to someone, right, I'm giving you this way to transfer to your rev, but only, you know, only this amount. You know, you have one call to this function to transfer rev to your account. You know, so I'm giving you this permission to transfer, right? And you can only transfer, you know, what we agreed. So this amount. This is like capability, right?
Yeah.
You're saying you're not saying I'm giving you a decker function, so you can, you know, say any amount you want. You know. Okay, so if I seal a contract that will create a transfer to your rev account, and I send you this unforgeable name to call it, right? You can. Sorry.
Which unfortunate name?
Unforgeable name that I'm thinking. Can you use it? Can you use the same logic for sealer and sealer, or you can create another one? So you can create sealer and sealer, and you can seal. So you can seal this transfer, and whatever sealer is giving you back is whatever sealer is giving you back is the reference to do unsealing. So if I seal a transfer and sealer will give me back the box, right? The reference, and I send you the box, so you can unseal the data, and you can call the contract. So you don't have access to anything else. Should I give you this unsealer or the box? Yeah, I'm not completely sure. Do you share unsealer or the box? I mean, you need unsealer and the box. This is the two things that you need. Yeah, this is like a public and private key, right? If you hold the unsealer, and you know, if I give you the box and I'm holding the unsealer, I can always know if you give me the right box.
So this sort of thing that, I mean, you have to you have to have a purse for the amount that you want to give permission to execute. The person could always take if they have a decker, they could always take the balance from the purse. All right. We could take up to the full amount. You're giving them the permission to.
But I'm saying that you in your deploy, you can create the continuation that will create a transfer, right? And you will execute this transfer only when you receive the right box. But I'm not sure how can you. I'm not sure how to do this like automatically, right? How can I be notified when you make this transfer? This is not. I'm still not sure how to do this, right? Because you don't want to check your balance that I transferred some reps, right? You want to write a contract and say, you know, when you give me the reps, I will execute this code. But how to detect? How can you say, oh, I received exactly a transfer that I'm asking? How to detect this in the code?
Well, you need. Well, actually, you know, if the contract is doing a transaction, right? If the contract is doing a transaction, okay, the contract has to has two sides. Now, let's say you're buying rock with ETH. It has to transfer the ETH and the rock, both or neither. Right? It has to know if it can reduce the ETH.
But I'm not sure how to detect this inside the rolling. How to detect that transfer happened?
Okay, well you have to be given a purse, right? You have to be given a purse.
I'm not sure. I'm not sure how to give a purse. I didn't find a way to create a purse or you know how to work with the purse.
Well, wait, you have is there an example down here? No. But that's what we did before, was we created a purse. Now, here it has an internal make purse.
Yeah.
But. Oops. Now, if you look at the make purse in the eWrite site, and that's what we probably should do first. What's going on here? We want to do okay, so the make purse is a method of a mint. Okay, where in fact, this is a beautiful example right here. This is exactly what we want to look at here. This is going to
yeah, this looks something Yeah.
Okay. I assume this is the example. What's a row spec channel? So, you know, we created first with the amount of the transaction, and then we pass that to the transaction contract, and it has to get the purse from us and the purse from them, and do an exchange. Of course,
Yeah.
it has to give me the right stuff.
So you can check. So
So
in your contract, you can check the balance.
We have to
Is the
check the
right
brand.
amount? And
We have to
okay.
check the brand of the purse.
Yeah. Yeah. Okay. Yeah. This makes sense. Yeah. Yeah. Mm-hmm.
So just create purse. Okay, this was oh, this is way Alice purse. Where's the make mint? Make mint.
Yeah. This
Oh,
is
I see the make mint here, but I don't see where it's putting anything into the mint.
it is created here. Beneath that, you have test create purse. The one below setup. Yeah. No. Test create purse. It is yeah, the setup and then yeah, test create purse.
But I guess I'm looking at was trying to look at where they execute setup.
It is not executed directly. It is on the top. It is specification of all tests. If you go to the top, you will see here row spec, test suite, setup, and then the list of tests. The first is the name. No, on the line 18. Yeah. In the first element in the tuple is the string of description of the test, and then the second parameter is the test. Yeah. And the row spec is executor of the test. Guys, I should go now.
Yep.
I want to check some other stuff for last panel state.
All right, guys. Good luck. Yeah, we should let you get busy.
Yeah, I'm hoping for next week to maybe have some initial version to test, but yeah, I still have stuff that I didn't test already, so I'm not sure how much time I'll do.
For which thing?
for last finalized state.
Ah,
This is the first thing that we need to do. So
yeah. So we don't call, we're not calling that a checkpoint or anything. It's just last finalized state.
yeah, last finalized state.
All right. Good luck with that, man.
Yeah.
Thanks.
Later.
Thank you. You too.
Right.
Bye bye.